Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hanif bin Ghazali. My matric number is GE200037. This paper is about air fryer using fuzzy logic. I use this paper because in this subject, which is computational intelligence, we learn about fuzzy logic. So this is a paper that implements fuzzy logic to use in air fryer. Okay, this paper is wrote by Abhar Tewari, Kiran Israni, Monica Kalani from BES Institute of Technology. Okay, next. The aims for this paper is presenting the idea of controlling the consistency of food using fuzzy logic control. This process is based entirely on the principle of taking non-precise input from the sensors, subjecting them to fuzzy arithmetic, and obtaining a crisp value of the cooking time. Okay, as we all know that air fryer is used to set the timer and the temperature that we want. So generally, the person will set the timer knob and the temperature based on the food type that they want to cook and the type of the degree consistency of food. But in this paper, they use sensor to detect this parameter, which is temperature, frying time, moisture content, thickness of slice of food, and food consistency. Okay, in this project, it has 4 inputs and 1 outputs. The 4 inputs is, first is temperature, second one is the frying time, the third one is moisture content, and the fourth one is the thickness of slice of food. Then for the output, there is one output for this project, which is the food consistency. Okay, as shown in this figure 1, which is the shape of the membership function, have the input, which is the 4 input, which is the temperature, frying time, moisture content, and the thickness of slice. And then go to the classification, and then go to the inference, which is the rule base will be implemented. And then next one is the declassification, and the last one is the output, which is the food consistency. Okay, for the next one, this paper will show about the membership function. For the first membership function, for the input temperature, it has 3 membership set and range from the 0 to 200. The membership is low, medium, and high. For the second one is for the input frying time. It has the range from 0 to 60. The membership is less, moderate, and more. And the third one for the input membership is moisture content. It has 3 membership, which is less, medium, more, that from range 0 to 100. And the last one input membership, which is the thickness of slice, which is the thin, medium, thick, and the range is from 0 to 100. Okay, this is for the membership function for the output, which is the food consistency. It range from 0 to 100. The membership set is not cooked, half cooked, and crispy. Okay, after they set the membership function, they must set the rule that implement in the project, which is they have 10 rules. For all of these 10 rules, they can choose which are the perfect temperature, perfect frying time, perfect moisture content of the food, and perfect the thickness of the slice to pick to pick out the food consistency at the output of the fuzzy logic. And after we set the rule of this fuzzy, we can see that from the rule of this system, the temperature is 156, the frying time is 46.6, moisture content is 50, thickness of slice is 50, then the food consistency is 77.4. This is the response surface of the input-output relations. For example, for this project, if we take the temperature is high, the frying time is more, moisture content as medium, and the thickness of slice as medium, then the food consistency, which model output is crispy. And here is the crispy consistency.